Welcome to Whiteboard Programming, where we simplify programming with easy to understand whiteboard videos. And today I'll be sharing with you the key types of machine learning that we should know and the differences between them. That is supervised versus unsupervised versus reinforcement learning. So let's get started. So, as we all know that machine learning, or short for ML, is a subset of AI that enables machines to develop problem-solving models by identifying patterns in data instead of leveraging explicit programming. Here, the learning refers to the training process in which the algorithms identify patterns in data and then use those patterns to tweak the model, aiming to provide a more accurate output each time. In this context, we can state machine learning types into supervised, unsupervised, and reinforcement learning. Let's look into each of them one by one. Starting with, what is supervised learning? So, supervised learning is a machine learning approach that's defined by its use of labeled datasets. These datasets are designed to train or supervise algorithms into classifying data or predicting outcomes accurately. And by using these labeled inputs and outputs, the model can measure its accuracy and learn over time. Further, supervised learning can be separated into two types of problems when data mining: classification and regression. In classification problems, we use an algorithm to accurately assign test data into specific categories, such as separating apples from oranges, or for example, in real world, supervised learning algorithms can be used to classify spam in a separate folder from your inbox. Some of the most common classification algorithms include linear classifiers, support vector machines, decision trees, and random forests, etc. And in regression, we use algorithms to understand the relationship between dependent and independent variables. But hey, you must be thinking, what purpose do they serve? Well, these regression models are helpful for predicting numerical values based on different data points, such as sales revenue projections for a given business for a particular business forecast. Some popular regression algorithms are linear regression, logistic regression, and polynomial regression. So in all, you can say that supervised learning can be used to make predictions, recognize data, and classify it. Up next, let's understand what is unsupervised learning. Now, on the contrary to supervised learning method, unsupervised learning uses machine learning algorithms to analyze and cluster unlabeled data set. These algorithms are made to discover hidden patterns in the data without the need of a human intervention, hence the name unsupervised. Unsupervised learning models are used for three main tasks: clustering, association, and dimensionality reduction. Here, clustering is a data mining technique for grouping unlabeled data based on their similarities or differences. For example, k-means clustering algorithm assigns similar data points into groups, where the k value represents the size of grouping and granularity. This technique is helpful for market segmentation, image compression, etc. Next, association is another type of unsupervised learning method that uses different rules to find relationships between variables in a given data set. These methods are frequently used for market basket analysis and recommendation engines, along the lines of recommendations that we see on platforms like Amazon.com. Next, dimensionality reduction is a learning technique used when the number of features, or aka dimensions, in a given dataset is too high. It reduces the number of data inputs to a manageable size while also preserving the data integrity. For example, very often this technique is used in the pre-processing data stage, such as when autoencoders remove noise from visual data to improve picture quality. Also, it's worth noting that unsupervised learning can also be used to prepare data for subsequent supervised learning. This is done by identifying patterns or features that can be used to categorize, compress, and reduce the dimensionality of data. Up next, let's understand what is reinforcement learning. Well, reinforcement learning is all about taking suitable action to maximize reward in a particular situation. It is employed by various software algorithms and machines to find the best possible behavior or path it should take in a specific situation to reach the ideal result. And here the computer generally employs trial and error approach to come up with a solution to the problem. To get the machine to do what the programmer wants, the artificial intelligence or AI gets either rewards or penalties for the actions it performs. And do remember that its goal is to maximize the total reward. Although the designer or the programmer sets what we call as a reward policy, which is nothing but the rules of the game. He or she gives the model zero hints or suggestions on how to solve the game, and it's up to the model to figure out how to perform the task to maximize the reward, starting from totally random trials and finishing with sophisticated tactics and superhuman skills. Further, it's worth noting that reinforcement learning differs from supervised learning in a way that in supervised learning, the training data has the answer key within it. So the model is trained with correct answer itself. Whereas in reinforcement learning, there is no such answer, but the reinforcement agent decides what to do to perform the given task. And in the absence of such training dataset, it is bound to learn from its experience. A perfect example of reinforcement learning is training a bot to play a chess game, while for supervised learning is object recognition. Up next, let's discuss about the difference between supervised versus unsupervised learning versus reinforcement learning. Starting with number 1, supervised ML learns by using labeled data, whereas unsupervised learning is where we train using unlabeled data without any guidance. Whereas reinforcement ML works on interacting with the environment to learn. Number 2, the aim of supervised learning is to calculate outcomes, whereas for unsupervised ML, it is to discover underlying patterns, and for reinforcement ML, it is to learn a series of actions. Number 3, the type of data used in supervised ML is labeled, whereas in unsupervised ML, it is unlabeled, and on the contrary, in reinforcement ML, there is no need for a predefined data set. Number 4, regression and classification are the types of problems accounted in supervised ML, whereas association and clustering are in unsupervised, and in reinforcement ML, it is exploitation and exploration. Number 5, a few applications of supervised ML include risk evaluation and sales forecast, whereas for unsupervised ML, we have applications like recommendation systems and anomaly detection, whereas major applications for reinforcement learning include ideas like self-driving cars. Number 6, some algorithms used in supervised ML are linear regression, logistic regression, SVM, KNN, etc. Whereas K-means and C-means are some algorithms used in unsupervised ML. And on the contrary, in reinforcement ML, algorithms like Q-learning and SARSA are used. Lastly, to answer the big question of which is the best to use among supervised versus unsupervised versus reinforcement learning, I'll say that it all depends on deciding the right approach for your situation, which can be only judged after assessing the structure and volume of your data as well as its use case. To make your decision, be sure to define your goals, evaluate your input data, and review your options for algorithms. By which I mean seeing to the fact that are there any algorithms with same dimensionality that you need, that is the number of features, attributes or characteristics, and can they support your data volume and structure or not. With that, I hope this video was helpful to you and served value. If you love my content, feel free to smash that like button, and if you haven't already subscribed to my channel, please do, as it keeps me motivated and helps me create more content like this for you.